Okay, can see the slide, huh? Okay, all right. Okay, thank you, Daniel. Okay, so let's start now. So matter, what is matter? Right. So as you can see, this is matter lah. Okay, matter is anything that has mass and it occupies spaces. Okay, so you can see this mass, it actually occupies some space and it has a mass. Okay, anything that occupies space must has a mass. So that is what we call as matter. Okay, so matter is anything that has mass and occupies spaces. All living things are matter, but not all living things are non-matter. So all living things like human, animal, plant, microorganism, all are matter, right? So for example, like animal, plant, human, and non-living things are like water, air, gas, soil, okay, rocks. Okay, all that are non-living things, but they are matter. Okay, there are things that they are they exist, we can see them, but they are not matter because they do not occupy space and they do not have mass, such as light. You can see light, but then light is not matter. Okay, but the lampu is matter, tapi cahaya daripada lampu is not matter because it does not occupy any space and it cannot be weight. You cannot weight, no mass. Okay, like electric current also is the same. Sound, you can hear them, you can listen to them, but they are not occupying any space. You cannot keep them in anywhere. Okay, so these are the examples. Can Am I too fast? Okay,
No.
thank you. All right. Okay, let's go to the next one. So, if a shoe is a mess, is a shoe a mess? Okay, is this book a mess? Is it a mess? Okay. Is air a mess? Air. Okay, is wind. Wind, is it a mess? Okay. Wind is a mess. Wind is actually what? Wind is not a mess. Wind name given for a moving air. Okay, it's actually a air. So it's actually not a mass lah. It's a name like wave. What is wave? Wave is actually the water moving in the sea. Okay, the water moving is what we call wave. But wave itself is nothing. Okay, it is actually the water. So sea water is a matter. But then the wave is not a matter because wave is the name given for the moving sea water. Understand or not? Can differentiate or not? Yeah. Okay, next. So we can see mass such as, okay, when we want to, you see when you take an empty bottle, okay, empty bottle like this, empty bottle, you try to squash the bottle. You cannot, you see, I cannot crush it. I cannot crush the bottle. Do you know why I cannot crush the bottle? I cannot crush it. See, you will be back to the original. Actually, no water. It's an empty bottle. But why I cannot crush it? Why do you think I cannot crush it? Who want to guess? Yes, correct. Because inside here, there are actually plenty of air, which I cannot see. But the air is occupying the empty spaces inside the bottle. So there is air in here. That's why I cannot press it. So when I turn it upside down and I want to insert it into a basin of water, okay, a basin of water, I cannot push the bottle inside because there is air inside here. So that's why water don't want to come in. That's why when you try to do it at your toilet, You try to do. Okay, you try to push an empty bottle inside, cannot. Unless you turn a bit where the water can come in, then only you can see the water coming in, because air can escape. When the air escape, you will see a bubble coming out from the water. Because air is occupying the space. Okay, so this like this. So you can see the water only come in a bit, but then there's an empty space here. Empty space actually is not empty. It's filled by, it is filled by the air. Okay, the air. Okay, so inside here, actually there are air, right? So air is occupying the space inside here. Okay, next you see a balloon. When we poke a balloon, you will see the heavier balloon will go here. Q is heavier than P, because air actually has mass. Okay, it occupies the space inside the balloon and it also has mass. That's why Q has more mass than P. That's why Q is heavier than P. Can? Okay, can just answer me using your mic. No need to comment also. Okay, so if I ask can or cannot, yes, it can or cannot. Okay, can guys?
Can.
Okay, next we go to matter. So matter has a property, ciri-ciri. Okay, matter actually has a property. One is a physical one, another one is a chemical property. So physical is what we can say, physical quantity is, or physical property, okay, physical property, ciri-ciri physical is what we can identify by using our 5 senses of human, or we can use a measuring tool. So we can see it, we can observe, okay, such as the color changes, the weight, okay, the weight or the density, and the solubility, the melting point. Okay, so like this, like sugar is soluble in the water. So sugar, okay, basically physical properties like this. It does not change into new substance. Okay, so physical property are property that can be observed without changing the matter into different substance. It doesn't change into another thing. Okay, it only changes its shape, but then it is the same thing. Okay, like sugar. Sugar, although sugar is soluble in water, it is still sugar. Still the same sugar, just that it melts in the water. Okay, like pot. We know pot is made of heat conductor because it can become hot and then it also can cool easily because it's a good heat conductor. Then some liquids we can observe the boiling point. Okay, boiling point is when it turns into gas. Okay, so the liquid turns into the gas. So the temperature where it start to turn into gas is what we call as the boiling point. When it reach the boiling point, the liquid will change form. It will change form, but it is still the same liquid. It's just changing its shape only. Okay, but it is still the same thing. Okay, so that is what is physical property. Okay, physical property, it does not change anything. It's just change the physical only, change the look only. But then it is the same thing. It does not change into new substance. Okay, can understand or not?
Can.
Okay. Next, we go to the chemical property. Chemical property is a substance that show a reaction when changes to different substance. So chemical is when it changes. Okay, like this. This is the iron. But when it changes color, you see it changes color. This changes color is not iron anymore. This brown color, what we call as rust, it is actually a iron oxide. So it is a mixture of iron plus oxygen. So it is a new substance. This is a new substance. This is iron, solid iron, pure iron. And then when it is exposed with oxygen, it get exposed to oxygen, it will react with oxygen and combine together to form the rust, karat. So the rust is actually a new substance, what we call as iron oxide. It is a mixture, it is a compound, it's a new compound, iron plus oxygen. So it become a new compound. So this is a chemical property of iron, where it can turn into iron oxide. See? So iron oxide is a new substance. It is not the same substance as iron. Like water, although it changed to liquid, it changed into gas, it is still the same thing. So this is physical property. But if it's changing into a new substance, this is not physical, this is chemical property. Okay, so like this, you see, we mix this picture. So you see it forms a new substance. We mix a spirit, we plus sugar, we plus a bit of soda, and then it turns into a new substance. So this is the chemical properties. Okay, like rusting is a chemical property. Like iodine solution is a brown color. But then when it reacts with starch, when it mixes with starch, it will become blue color. So a blue color is the new compound. Okay, so when it change into a different substance is what we call as chemical property. Can?
Can.
Okay. So there are two lah. So physical is not changing into new substance, it's just changing its physical only. But chemical, it changed totally into a new substance. So that is the difference. Okay. Next, we can classify a substance, okay, based on variety of characteristics. So basically, there are 4 characteristics. So you want to differentiate between substance A and substance B. How do you differentiate? What are the things that you should see between A and B? So there are 4 properties or 4 characteristics. One, you see its density. Are they the same density? If they are the same density, meaning they are the same substance. If they are different in density, meaning they are different substance. They are not the same. Then you can see their boiling point. Are they changing? Okay, are they changing their state from liquid into gas, at the same temperature, at the same boiling point? If not the same boiling point, meaning to say they are different substance. Okay. Next, you see their melting point. Melting point is the temperature where the solid turns into liquid. Solid, keras, it becomes liquid. How? So it turns into liquid when it reaches the melting point. So you see between A and B, are they changing their state from solid to liquid at the same temperature? If not the same temperature, they are different. If they are the same temperature, meaning they are the same substance. Lastly, you can see their solubility. Okay, so solubility is the ability of substance to melt or to mix with solvent. Let's say you mix water, you mix sugar. So are they soluble at the same solubility? Okay, if not the same, then they are different in property. They are not the same property, meaning they are the different substance lah. If they are the same, all same, meaning they are the same property. Okay, meaning they are the same thing. Okay, so we can see the density. So density is mass unit of substance. It's a less substance will float. Okay, less dense substance will float. Denser substance will sink. So example like oil float on the surface of water because oil is less dense. Okay, let me show you a bit. Okay, can you guys see this picture? Solubility is the ability of substance to dissolve, okay, to larut, dissolve in a solvent to form a solution. Okay. So we see mixture of glycerol and water. So glycerol will sink, water will float because water is lower density than glycerol. Mercury. Mercury is known as quicksilver. Other name is what we call as quicksilver, or we can say a liquid silver. It's a silver, but then it's a liquid one, liquid silver. So this is mercury. So silver is heavy lah, because it is a metal. So mercury will sink because it has higher density, but petrol, oil petrol will float because it's a lower density. Sand and water, of course sand is sink lah because higher density, and water will float. And then oil and cork, tabus. Cork is like is a like cardboard like that. Okay, so cork will float and will sink because oil is higher density. So you can see this is the density tower. We call this density tower. So you can see on top is the most less dense. Okay, most, and at the bottom is the most dense. Okay, so you can see the oil lamp is on top, and then alcohol, and then vegetable oil, and then water. So vegetable oil will float, it's lower density than water, and then dish soap will sink, milk will sink, syrup will sink, and honey is the most density. And then lastly, you can see like what is this? I think this is a screw.
A bolt.
Huh? Bolt.
A bolt.
Like screw lah. So it sinks the most dense. So for example, you can see layer T, 3-layer. Okay, wait, got a lot of message coming in. What is this? Okay. So like 3-layer T, you can see T is the most less dense, and then milk, and then the sugar. Okay, the sugar, or we call syrup. Syrup is the most dense, and then tea will float lah, and then ice is the most less dense. Ice will float on top. So you can see here is the density lah, different. So why they can float, why they can sink? Because all of them are different. They are not the same property. Okay, so this is based on the density. And okay guys, so far so good.
So far so good.
Okay. 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 So this is the famous density tower, another density tower. So we can see alcohol is on top. Alcohol is like the beer, the beer lah, like the Carlsberg lah. The sanitizer also is alcohol. So when you put sanitizer, you mix with water, you will see sanitizer will float on top. Okay, because sanitizer is alcohol. Okay, so alcohol is made of only carbon and hydrogen. So hydrogen is very light lah, very light, very ringan. So that's why it is float on top. Okay, and then it do not have oxygen. Oxygen actually has more mass lah. It has more mass. Later on. Okay, and then oil at the middle and water on the bottom. Okay, because water has oxygen, so it is the most dense because oxygen is more than hydrogen. Okay, so hydrogen followed by carbon followed by oxygen. So oxygen is the most dense, hydrogen is the most less dense. Okay, that's why you want to float a balloon, you will use hydrogen or helium because they are very light. Okay, that's why they can float in the air. Alcohol is only made up of carbon and hydrogen. They do not have oxygen. So that's why they float. Oil also same, only have hydrogen and carbon, no oxygen. So that's why it floats. And then water has hydrogen and oxygen, H2O. So that's why it sinks at the bottom. Okay. All right. Next is the melting and boiling point. So, like just now I said, melting point is a temperature when solid change to liquid. Okay, melting, it melts. So it's when solid change to liquid. So that is melting point. If boiling point is where solid turns into gas. Okay, liquid or liquid change into gas. You can see air has a melting point at 0, meaning 0 degrees Celsius, it will change into another form, it will melt. And then 100 degrees Celsius, it will change into gas. Alcohol, you see, negative 117. Very, very, very low temperature, it already changed into liquid. And then at 78 degrees Celsius, it can change into gas. Okay. So we can see here, the water punya melting point, 0 is the melting point. So like this, So negative 218, negative 117, 0, and 1085. Okay. So this is the degree. So you can see at negative 218, oxygen will turn into gas. Sorry, oxygen will turn into liquid. Okay, into liquid. Then at negative 183, it will change into gas. Because oxygen, you can see melting point at negative 218, and then at negative 183, it already exists as. That's why at our room temperature is about 23 degrees Celsius. So that's why at this temperature, it is already a gas. You cannot see any liquid oxygen. You cannot see. Okay. And then for water, 0, it start to turn into liquid. And then at 100, it start to turn into gas. Okay. Below than 0, you can see it. Okay, it's a solid. So alcohol is below than 117 is a solid. If more than 117, until 78 is actually a liquid. After 78, it will turn into gas. Copper. Okay. Copper, you see, to melt it, untuk mencairkan the copper, very, very, very high. Because that's why in our room temperature, it exists as a solid. Even 100 temperature also is still a solid. 1000 degrees Celsius also is still a solid. But after 1085, only it start to change into liquid. A molten liquid, we call it a molten liquid, like the magma. Then at 2562, very, very hot, very, very hot, only it changed to vapor, water, it changed into gas. Okay, so this is a different boiling point. All substance have different melting and boiling point, not the same. Okay, can understand or not?
Can.
Can.
Okay. All right. Lastly, we can see just now Kahong says solubility is the ability of solute to dissolve a solvent. So guys, I want to show you this video. Yeah. Wait. How do I select? Okay, it's okay. Cannot show you because I think my PowerPoint having a problem. Never mind. I will sing the link later so you can see. Different substance have different solubility. Not all substance have the same solubility. Okay, so not all substance can dissolve in water easily. So if you mix you put a sugar and a salt. Which one dissolve better? What do you think? Sugar and salt. Okay, if you stir at the same, you stir 10 times, this one also you stir 10 times, the water temperature also is the same. So which do you think will dissolve more faster? Huh. Okay, this one you find out. Okay, you find out. You try your own. You try at home. You put must same must be the same You cannot put so the water must be at the same volume. You put same glass same glass, same volume of water. You put two spoon 2 spoon of sugar, 2 spoon of salt. Okay, and then this one you stir, maybe you stir 20 times. This one also you stir 20 times. You try to see which one dissolve more better. Okay, this which one dissolve or solute, it dissolve faster. Okay, you try your own. Okay, then later you can comment. You can sugar should dissolve faster. Sugar molecule are bigger. Okay. All right, copy from Google. Okay. This one you find out your own Okay, so different solubility. So like this one Okay, actually I want to show this video. Okay. So you can see different substance. This one already dissolved already. But this one didn't dissolve. This one totally didn't dissolve at all. Okay, but this one already dissolved. So this one has the most lowest solubility. All these three has the highest solubility. Okay. Okay, so we are done. 5.1. Okay. Can we take a break for 1 minute? Minum dulu. Okay. Ada susu ke, ada kopi ke, minum dulu, rest dulu. Hanya kelas 10. Pakai kelas 10. Okay. Can we continue, guys?
Can.
Okay, let's continue. So, as you all know, and I also already repeat this many times, especially when I'm explaining the water cycle, right? So as I explained the water cycle in chapter 7, and then again in chapter 9, we got 2 times of water cycle. So I already explained that water can actually exist in 3 states. Okay, so the 3 states are actually solid. Okay, when they exist as solid, they are called as ice. When they exist as liquid, they are called as water. And when they disappear, boom, in the air, so they are called as water vapor. Okay, or sometimes we call as steam. Okay, steam. So the cloud is actually liquid. Okay, just that you can see the clearly because it is attached to the dust. It is attached to a lot of other molecule as well in the air. That's why the cloud are visible to us. Okay, so let's see the kinetic theory of matter. This is the favorite question. Favorite question. So they may ask you, describe kinetic theory of matter. So you must know how to describe. So kinetic is movement. The movement of the matter. Matter is this round shape. Okay, or we call it particle. So matter consists of tiny and discrete particles. Okay, these are the particles. In chapter 6, you will learn what is inside the particle. Okay, what is inside the particle? Got proton, got electron, okay, got neutron. You will learn. But now you just need to know this is known as particle. Okay, so the particle, okay, it is actually an atom lah, but then we call it in chapter 5, we introduce it as particle first. Later only we will see what is the particle name. Okay, is it atom or is it molecule? Okay, so later only we will see. But now we will call all this as particle. Okay, so these particles are what fill up the space and what give a substance its mass. Okay, I repeat one more time. These particles are what filling up all the space and giving the substance its mass. Without this particle, there are no mass. Okay, with this particle only, a substance can have its own mass, and you can see it is filling up a certain spaces. Okay, so can everyone read together? Okay, everyone open the mic. Read loudly together. Okay, matter consists of tiny and
Matter consists of tiny and discrete particles and always move in all directions.
Matter consists of
Matter
tiny and
consists
discrete
of tiny and
particles
discrete
and always
particles and always move in all directions.
Iris.
Okay, good. Okay, so that is what we call as the theory movement of matter. So matter consists of these tiny and discrete. Discrete meaning they are separated, they are not combining, they are separated. So they are tiny and they are discrete and are always moving. They are always moving. They are not standing still like that. They are always moving in all direction. That's why you try to stand still in 1 second. You try to stand still. Can you like really stand still? Sure cannot, right? Okay. One of the reason is because your heart is beating. Your heart is beating and there are actually movement. Okay. The movement of the matter. The matter actually moving, just that you are not seeing it because you are actually in a solid state. Okay. But they are actually moving in all direction. That's why human, they cannot stand still and they will surely like a bit of movement. Okay. However, they try to stand still, also cannot. Okay. So we see the examples that show a matter is made up of tiny particles. Okay. So at the first stage, this balloon is filled up with a gas. Okay, a gas from the Bunsen burner. Okay. So it is filled up with gas. After some time, you see the balloon deflate. It deflate. Pecut. Okay. So a balloon filled with gas is left aside for a while. It shrinks because gas is made of small particles. So gas is actually discrete and small particle and it can diffuse, it can pass through the tiny pores, the lubang-lubang kecil. So actually a balloon ke anything, actually they has a very tiny particles, tiny pores. Pores is a very small hole. You can only see the pores using microscope. With your own eye, you cannot see. Okay, using microscope only you can see, oh, actually there are a lot of pores. So they can escape through the pores on the wall of the balloon, so the balloon becomes smaller. Next, as you can see, this is liquid. Okay, this is liquid water. When you pour potassium 7 manganate crystal, this is actually like purple in color. Purple in color. after 20 minutes, you can see the purple color already mixed up, okay, evenly with the water molecule. Okay, so they can pass through the water molecule and they can dissolve in the water. So that's why the water in the tube becomes purple and the potassium manganate dissolve in the water. Its particle move further apart, they distribute evenly. They are evenly distributed among the water particles. So this is the potassium. Let's say I use purple color. Okay, so the purple color are actually, they fill up all the empty spaces between the water molecule. So that's why they stay together. So that's why you can see the water changes color after 20 minutes. 可以吧? Can or not? Okay, thank you.
Can.
Okay, so like this lor. So this is the potassium manganate, but this is a liquid. So you can see here, actually, here are all the water molecule. Okay, water molecule. All right. So actually between the water molecule, there are tiny spaces. There are small spaces. So this potassium manganate, after some time, it can start to fill up the empty spaces. So that's why after some time you can see they are distributed evenly. Okay, all the same. So they are distributed evenly. So that's why you cannot see any more separation. Here you can see it is still separated. Here is still white, here is still purple. But after some time, no more separation. They are even, sama. Sama rata. Okay, Melayu kata sama rata. Dia sama saja. Okay, they become one. Okay. Next, we go to this one. Okay, this one is a very famous question also. Okay, very famous. So we can see the susunan, the arrangement of movement of particle. So physical property for solid first. So solid, they have a fixed shape. So that's why they exist in this shape. They exist in this shape. Okay. So you can see the shape are not changing anymore. Okay. Unless you heat it, it turns into something else lah. They are actually okay. So that they exist in their own shape. They have a fixed shape. Their shape are not changing anymore. Okay, so that is the solid. And then they also have a fixed volume. So the volume is always fixed, not changing anymore. Okay, like this bottle. This bottle, it is 1500 ml. So the volume is 1500 ml. So it is not changing anymore because the bottle itself is a plastic, is a solid. Okay. Okay, next, the space between the solid are very small. There are very small space and they cannot be compressed. You see, I try to compress, cannot. It cannot change into another thing. So I cannot compress a solid easily. Cannot compress. And then they are very close together and well arranged. Okay, the arrangement of the particle are very close and well arranged. And the movement of particle, they are vibrating. Actually, they are vibrating like this picture. They are vibrating, but at their own position. They didn't go to another position. Like this, they go to another place. This one or go many places. So they are vibrating at their own position. Okay. And example are like wood and so on, like the books and so on. Okay, next, for liquid, they have no fixed shape. So whatever shape you give, you pour them in this bottle, so they will follow the shape of the bottle. You pour them in ice cube, okay? The acuan to make the ice cube, they will follow the pattern of the ice cube. You pour them in the plastic bag, okay? The teh or lah, Milo or lah, you put in the plastic bag, ikat tepi so they will follow the shape of the plastic bag. So they do not have any fixed shape. So that is liquid. no fixed shape, but they have fixed volume. The volume is always fixed. So let's say I pour, this shape is 1500 ml. So if I pour in the water also have the same volume as the shape, which is 1500 ml. So the volume is always the same as the shape. Can or not? Can,
Can.
So that is liquid, remember. No fixed shape, but fixed volume. Okay. Then the space between the particle are actually small, okay, small and difficult to compress. Not so easy to compress. They can compress, but not so easy to compress and difficult to compress. Solid totally cannot compress. Okay, and then the arrangement are very close. Okay, close but not arranged in the fixed position. They are not fixed, so if let's say you move the water, it can move also. Okay, because they are not fixed at their own shape. Okay, they can move anywhere, right? They can move. So they are not fixed in the fixed position. Okay, so the pergerakan, the movement, they can move freely. Okay, you see? Move freely like water. Okay, so that is liquid. Okay, next, gas. Gas, no fixed shape, and also no fixed volume. Okay, no fixed volume. And then it follows the shape of the container, right? So the space are very big and can be compressed. So you can compress them. So that's why you can have a oxygen tank, you can have the gas tank. So inside are actually gas. So the gas are actually compressed. Okay, they are very compressed together. You can compress them. And then they are arranged far apart and scattered. So you see, they move anywhere as they want. Okay, and then they move freely and random in any direction. They can go freely and move in any direction and very random. They can go to left, they can go to right, they can go anywhere. This one move, but then not so fixed lah. It is not so fixed, but it can move freely. Okay. Okay. Ken, any question on arrangement of particle?
No question.
Okay, good.
No question, teacher.
Crystal clear? Clear, very clear. Okay. Next, we go to diffusion. Okay. So, what is diffusion? Okay, everyone read together. 1, 2, 3. The process of movement of matter, particle.
The process of movement of matter particles from high concentration
Metal
region
particles from high
to low
concentration
concentration
region to low
region.
concentration region.
Okay. So diffusion is the process of matter. Let's say you put a potassium manganate just now. It is purple. So you can see the purple in color. It will move from a very concentrated. So they are together. Okay, very, very concentrated. They will move to a region or to a place where low concentration. So here they will move to a place which is less concentrated. Okay, and then they will move. And then after a while, they will be spread. They will spread evenly. So that is the process of diffusion. Okay. So for example, like this one. Okay. So you see they put a copper sulfate. Okay, copper sulfate crystal, which is blue in color. So they put in a gel. So the gel is a solid. Okay, a gel is a solid. You see, it's a solid. So a gel is actually a solid. So the particle are very closely to each other. Very, very close to each other. That's why for the copper to diffuse, it wants to flow from a high concentration to a low concentration. It will take a few days. 1, 2, 3, 4 days. Okay, only you can see it is spread evenly. So very long time because it needs to pass through a very, very close, a very, very small space. okay, between the particles. So that's why it is moving very, very slowly. It diffuses at a very slow rate. For liquid, you can see liquid is actually a, so for liquid, they are particles, but the particle has a more space than solid. So when you put a copper sulfate, the same thing, the blue, you can see the water turns blue after 2 hours only. This one, few days, because gel is a solid. Next, this one, you put a bromine gas. Bromine is brown in color, brown in color. So here you have all the particle, the air particle, which are very far from each other. The particles are far from each other and the spaces between them are very big. So that's why you can see the bromine can flow, can diffuse through after 50 minutes. See, it is already occupying the jar B. Okay, this is jar A, this is A, this is B. After a while only, because the air is having a very large space between them, and that's the reason lah. This one space very closely to each other, so it is more slower. This one very, very close to each other, that's why very long time to diffuse. Okay, so far so good.
So far, so good.
Okay. So the reason is because you need to know, it is because the space between the particles in solid, in liquid, and also in gas. That is what makes the diffusion rate fast or slow. Okay. One more thing about diffusion. When you have a food. Okay, can you guys see this? Can or not? Can, okay. I scared later I draw you cannot see. Okay. So a food which is hot, when they are hot, the particle, okay, each food will release their own molecule. Food will have their own molecule. That molecule can actually spread to a place with a lower concentration, so they can diffuse through a place with lower concentration, so you can smell you can smell it, okay, even in the far distance. So because the molecules, okay, is traveling and diffuse through in the air and reach our nose, so that's why we can smell it. Okay, so hot molecule, let's say a hot food and a cold food, you can smell a hot food better than the hot food. That's why when your mom is cooking, okay, your maid ke, your orang gaji apa ke is cooking at the kitchen, you can actually smell even you are in the room. Why? Because the smell, okay, the food is very hot. When hot, they got a lot of kinetic energy. They got a lot of energy. So they can move very fast and diffuse through the air particles and reach your nose. While cold food, you can very hard to smell in the far distance, because when it's cold, the molecule are not activated. Okay, they are not as active. They do not have heat energy, so they are not very active. So that's why they do not travel in a very far distance like a hot food punya molecule. Understand or not?
Can.
And so this one very important. It's not explained in your textbook, but then it might come out in the exam. I don't know. So if come out in the exam, so you should know. If let's say people bakar sate ke, do barbecue ke, cooking ke, anything lah, so you can smell the food, because the molecule from the food travels and diffuse in the air, and plus if it is a hot food, it has a lot of kinetic energy and it can travel in a very far distance to reach our nose, while cold food cannot. Okay, that's the difference. Okay, next, this one simple only. So the change of state of matter. So liquid, when they are cold, okay, liquid is cool. When liquid is cool, it becomes solid lah. it turns into solid. Why it turns into solid? Because the heat is released. Heat is released, so the particle lost its kinetic energy. So you should know, heat energy, when we provide heat energy to any particle, the particle will absorb the heat energy, and they will convert the heat energy into kinetic energy. So kinetic energy is actually a movement, is a movement energy. It can cause you to move. So more heat energy meaning more movement energy. So the particle will move more. Okay. So when they are cool, heat is lost. When heat is lost, kinetic energy also is lost. So the particle cannot move anymore. So they will become close to each other. When heat energy increase, kinetic energy will also increase, so they can move. They will change into gas, or they will change into liquid. But when you cool them, you sejukkan dia, so the heat energy will be reduced, and the kinetic energy also will be reduced, so there are not many movement energy, so the particle will close to each other. So that's why it becomes a solid. So particle loss of kinetic energy and move slower, thus becoming a solid. Okay, when solid is heated, heat is absorbed. So when heat is absorbed, more kinetic energy. So the particle gain addition of kinetic energy and can move faster. So it changes into liquid. And as you provide them with more heat energy, they will have a more kinetic energy. So they will change another time into gas. Okay, can? Simple this one, very simple Okay guys, boleh?
Can.
Okay.
Okay.
So like this So this is a liquid. So when heat is absorbed, it turns into apa ni? Heat is absorbed. Oh, so kenapa macam pelik saja ni? Heat is released. Correct. So when heat is released, so it has no kinetic energy, so it become close to each other and form a solid. Like this, a liquid, when heat is absorbed, it absorbs heat, so it has more kinetic energy, so it will vibrate more faster and it will move in a lot of direction, so it can change into gas. Okay, so when they change into gas, they also increase in volume, and they also, this one very important, they expand. Because you see, when they are close to each other and when they are having a lot of energy, and when they have even more energy, so you can see the particle are having more space. Therefore, the volume increase. And the size of the substance, let's say this is the substance, will expand. They will expand. Okay, because they have high kinetic energy. So the size will expand. Okay, while if you cool them, the heat is released, no energy, so they decrease in the volume and the object contracts. Okay, so the reverse of this is it will contract lah. Okay, so okay, I skip that one. So this one you see this is the graph of temperature against time. Okay, so this is 0 degrees Celsius. This is 100 degrees Celsius. Okay, let's not 0. Let's say this is 0 degrees Celsius. So you can see when the temperature increases, the temperature are in their own state. This is in their own state. So they can exist in the solid. Okay, solid. But once they reach the melting point, like water, like water is zero lah. Once they reach the 0 degrees Celsius, they will start to melt. So this is the process. When the process is happening, we call it melting. When the process is happening, the temperature does not change. It does not increase or it does not decrease. It maintains at the same temperature. So this is the process takes place and the temperature does not change. Okay. Once they already completely change into liquid, okay, then the temperature will start to increase again. Will start to increase. So this is in the state of liquid lah, totally in liquid. This one is solid. Then they will stop. Once they reach 100 degrees Celsius, which is the boiling point, they will stop. So when they stop, the temperature does not change anymore. So this is the process where the boiling will happen lah. So you boil. So it will change into gas. So until all the gas are already changed into gas, so only then the temperature will start to increase again. Okay, so you must remember. So if I put A, B, C, D, E. So A to B, as they increase, they are in the solid state. But once they reach the melting point, the temperature will stop. Okay, and the process will happen lah. Melt, will melt all the solid into liquid. So therefore, no change in the temperature. But once they completely change already, then it will continue to increase. So in this state, they are called as liquid. Liquid. Once they reach a boiling point, all the liquid will be changed. So when they change in the boiling process, so no change in the temperature. The temperature will remain constant. And then after all the liquid have already changed to gas, so then only it will start to continue to increase and so on. Okay. So this is the graph that is very important. Favorite question. Okay, boleh faham tak yang ni?
Can understand.
Yana? Who have any question? Need me to repeat one more time?
No.
No.
Yeah, just you need to remember when the process is taking place, let's say melting ke, condensation ke, freezing ke, ataupun evaporation ke, there's no change in temperature. The temperature will remain the same. But when they are in their own state, let's say liquid ke, gas ke, then the temperature can increase or can decrease. But once they reach the melting or boiling point, the temperature will be same. Okay, because they are undergoing the process. Okay, the process is taking place to change the state. That's why no change in temperature. Okay. Okay, so we can see that in this experiment, a metal ball, before we hit the ball can actually pass through the ring. The ring boleh masuk. But after we hit the ball for like 5 minutes, you see the ball cannot pass through anymore. It cannot pass through the ring because the solid expand and the quantity of particle is not changing. Quantity is not changing, but the solid expand because the space of the particle become larger. They got a lot of kinetic energy. This one, they are very close to each other, no kinetic energy. But when you hit them, they want to move. That's why the kinetic energy, that's why they expand in size. But they do not expand like totally expand macam balloon lah. They just expand a bit only. Okay, right. So temperature increases when the substance heated and temperature decreases when the substance cooled. The change of matter enable variety of occurrence and phenomena occurs. Okay, so such phenomena we can see. These are the phenomena when a substance expand. Expansion of matter. So you see inside here is actually a mercury. It's a metal. Mercury is a metal. So when you place it in the hot substance, so the hot substance will actually give a lot of heat to this part. So this part is actually the mercury lah. So you can see the mercury are expanding. That's why you can see they give you the temperature reading. So the temperature reading is given by the mercury. So because the mercury expand in size, so as they expand, so you can see they are moving. So the expansion is like in the mercury lah, in the thermometer. Okay, another one, you can see the track of the railway, the kereta api, kereta api punya track will actually expand. During hot time, they will expand. When they expand, they will actually bend. They will bend lah, because when they expand, they cannot expand, they will bend. So that's why gap are given. You see, when they want to build this, they will give a small gap. These small gaps is to allow the metal to expand during hot day. So when they expand, so they tak bend lah. So they can expand they can expand. Jadi dia tak bend. Kalau dia tak boleh, dia tak ada space, dia will bengkok. Next, the cable the cable wire, you see, all the cable wire at the roadside you can see are actually very loose, because at night they are very cold. When they cold, they will kecut. When they kecut, they can putus. Dia boleh putus. Okay, and very hot time, if let's say you place ngam-ngam like this very tight so during hot day, the metal will expand. So when they expand, they cannot expand, they will putus So that's why when you give a loose one, so they can expand suka-suka dia lah. Dia boleh expand, dia boleh kecut. So no problem. Okay, to allow the expansion and contraction in the weather. And lastly, when you cannot open a metal lid, okay, penutup penutup yang besi, you cannot open. Let's say you want to open jam your jam or your peanut butter. Okay, so if you cannot open the metal lid, you can put it in the hot water. Put it in the hot water, so the metal will expand. It will expand in size, but so it will expand. So you can open it easily lah. Okay, but the glass does not expand. Glass will expand, but then metal will expand more faster than the glass. So as the metal expand more faster than the glass, so you can open it easily. Okay, put it in the hot water. So that is the tips in how to open a very tight metal lid. Okay. Okay, so we are almost finishing already. So the change of state of metal. So we can see freezing. Freezing is when liquid changes into solid at freezing point. Okay. And we have this one, sublimation. So sublimation, so as you learn, solid, this one I repeat many times already. So I just go very quick. So solid to liquid is known as solid to melting. Liquid to gas, if direct heating, it is boiling. If no direct heating, is evaporation. Okay. From gas to liquid, condensation. And from liquid to solid, freezing. Okay, but from solid directly to gas, solid straight away change to gas, and straight away change to solid. What we call it?
Sublimation.
Sublimation. Okay, this is sublimation, where the solid changes directly to gas and the gas changes directly to solid without going into liquid state. So we can see example is this one, dry ice. So this is actually a solid, but at the room temperature, it will quickly change into gas without becoming a solid, without becoming a liquid. So this one, dry ice. So you can see the dry ice. So it is a solid, but then it's straight away directly changing to gas without going into becoming a liquid. Another one is the mothball. So ini kita panggil ubat gegat. Kalau Melayu dia panggil ubat gegat. So ubat gegat ni dia ada bau lah. Okay, it has a very strong smell lah. Okay, usually people will put in the toilet, people will put in the cupboard. Okay, to avoid bau yang busuk. So as time goes by, you can see the morph will decrease in size, will become smaller. It is solid, no. Tapi macam mana dia boleh jadi, dia boleh hilang dia boleh mengecut? How it can become shrink? How it becomes shrink? How the mothball becomes shrink? So it actually undergo a sublimation process. Okay, it sublimates into becoming gas. Okay, without we can see the gas, but then at a very, very slow rate, very, very slow. Okay, usually it would take like about 2 weeks, 3 weeks baru dia boleh kurang. Tapi in the meantime, it will change into gas. So that's why you cannot see it in the air. Okay, boleh faham tak? So sublimation. So these are the examples lah. Okay, thank you, Kak Hong. Alright, so this is the dry ice used in the concert. So usually concert you will see a lot of asap So this is not asap tak ada orang bakar sate ke, tak ada orang masak. No. This is actually dry ice. They use dry ice. So they will put in a machine. So in the machine they will put the dry ice. So the dry ice will be pumped out. Pump out. So you can see here is the pump. So it will pump out all the gas. So you give a good effect lah. Okay, macam ni. Okay, so this is actually a dry ice. Okay, next is the condensation. So condensation is where water vapor change into liquid. Water vapor change into liquid because loss of heat. When they loss of heat, okay, gas, loss of heat, they will turn into liquid. They will become closer to each other. Okay. So for example, like this. So the surface of the glass is cold. Okay, the surface of the glass is cold. So the air molecule, when they touches the cold surface, let's say you come out from your car, okay, kamu keluar daripada kereta kamu duduk dalam aircon. Bila kamu keluar, so your surface of the glass is very cold. So the air molecule from the outside will touches your surface and straight away it will turn into liquid. So it will form a liquid. Okay, a liquid on the surface of your glass because your glass is very, very cold. Sama juga macam cawan. So when you place a cold water, it makes the surface outside here very, very cold. So the molecule, the air molecule from outside, which is the gas, when it touches the cold surface on the cold water, so it will directly change into liquid. Same like the fog and the cloud, same thing. Like the cloud, this is the fog ataupun Melayu panggil kabus. So kabus is when during raining, hujan, it will make the surface, the land surface cold. So when the land surface are very cold, okay, because due to raining, it will make the land surface very cold. So when the air molecule on the surface of near to the surface of the the air molecule which is near to the surface of the earth, okay, they are very cold, so they quickly turn into becoming a water molecule. So it's actually it's a gas lah, it's actually a gas, kan? Tapi bila sejuk, sangat-sangat sejuk because of the earth surface is very cold after raining, so dia menyebabkan the air molecule here also becoming a liquid. But then it's a visible one. So a visible liquid near to the surface of the earth is what we call as the fog. So all these are actually condensation process. Okay. That's why next time charge your battery. You know the class is until what time, so you need to charge, okay, or you use power bank. If not, this kind of thing will happen. Okay, never mind. Next time do not repeat. So next time sediakan payung sebelum hujan. Okay. Lastly is the boiling. Okay. So boiling, you know lah. Liquid change into vapor at boiling point. And then evaporation is where the liquid change into gas. Okay, this one with direct heating is boiling. Without direct heating, if let's say the sun only, is actually a evaporation. So you can see evaporation happen in making the salt. Okay, so salt water. So this is the salt water, seawater. Seawater has salt and also it has water. So around here is the water lah. Okay, around here is the water. It's a mix. Okay, it is mixed. Okay. So how they produce the salt is how they will take the salt water, they will place on the flat surface. Okay, on the permukaan yang rata lah. Okay, like this. Okay, they will put banyak-banyak air tu mereka akan letak di sini. So what will happen under a hot sun? So the water will evaporate. All the water will evaporate into becoming gas. So last yang tinggal hanyalah the salt. The salt will be left out. So you see, actually this one is a water mixed with the salt. But after all the water already been evaporated, it only left the salt. So they can get the salt from the seawater through evaporation process. Same. How you want to make a fresh water from a seawater? So you can use this method. Okay. So you see, we can take a cup and then so in this cup, sorry, not the cup. You can take a container, you fill with seawater. Okay, very salt. And then you place a plastic and then you tutup the plastic. Okay, and then you put a stone so to make the plastic rendahkan the plastic. Okay, and then you put a cup inside the container. So what will happen when under hot sun? So the water will evaporate. Water will evaporate and touches the surface of the plastic. So when it touches the surface of the plastic, the water here is actually the fresh water, without mixing with the salt. So the salt actually tinggal dekat sini, dekat luar sini. So all the water will be evaporate, and when they touches the surface, they will fall into the cawan. So you get a fresh water, while the salt water is left outside. So this is how to get a fresh water from a salt water. Same like this one. So they place a salt water, and then all the water will be evaporated, and the water will be flowing through on the surface to the side, and then all this fresh water will be collected in this plastic lah. So you can take this plastic and drink the fresh water. So inside here are all the salt. So this is evaporation process. Okay, so that is all for today. Okay. Any question?
No question.
So in the phase of 5, how much you really understand topic 5? That is all about topic 5.
4.5 to 5.
4.5. You can comment down. Okay, comment down. Okay, so now let's quickly take a quiz to test your understanding. Okay. Maybe we will end about 11:40 lah kot. Okay, we will try to end at 11:40. Can we end at 11:40? Can, okay, thank you. All right.